It. Hey, this is Jay Faulkner. You're here with my open source office hours, and we have kind of an exciting thing going today. I've got Glyph here with me, and so I figured I would start out a little bit with a story of how I know Glyph a little bit because this is fun, and whether you realize it or not, sort of a formative influence in career direction for me because we were working together in the San Francisco office of Rackspace. We were joking before the call started that longer ago than we want to count. Back in the Rackspace office in San Francisco, and I was an operator trying to get Rackspace on Metal online, and I didn't understand a lot about programming, but that's what you had to do to get it done because everything, once you get into automation, the difference between ops and dev really does start to go away in a hurry. And I just remember sort of struggling with something Python, and I asked Glyph if he could help, which seemed ridiculous to me because like he's like the twisted guy. Is he really gonna have time for me? And he came over to the whiteboard by my desk, and I believe at that point you were teaching me multiple inheritance in Python, or like once it was how promises are different from callback style eventing workflows. Those are the two specific ones that stick. So that means you must have done it dozens more times that I don't remember. And so that was sort of encouraging to me. And so I'm glad to have Glyph here, so that we can talk a little bit about his history, like where he's come from, where his knowledge has come from, sort of go from there. So first, I just wanted to give you a chance to talk a little bit about like where you come from, where's your career, like you kind of have like the 5 minute quick of what made Glyph where what he is today.
Yeah, well, that's an interesting. It's always interesting to try to compress it a little bit. I've had a varied and eclectic career. I should say first, thanks for having me. It's great to be here. Um, but yeah, my career began in New Jersey, writing vertical market database integration software for jewelers. That was my first job out of school. They had an application that was written in a custom, it wasn't FileMaker, but it was kind of FileMaker-ish access type database for Mac only was their product originally, and then they wanted
And
to rewrite the
that's
whole.
real Mac, I'm assuming, right? We're
Yeah,
talking like
yeah,
System
classic.
7, System 8 at that point.
Yeah,
Yeah,
yeah.
okay.
System 8 was the preferred platform to deploy it on, and I came in to rewrite the whole thing in Java. And that was my introduction to rewrites being a bad idea. It was a huge disaster, top to bottom. They did eventually ship a product, but it was several years after I left. Um, and that's actually kind of, I mention it both because it's kind of an interesting, weird place to start, but also that's sort of how I got into open source in the first place. On an open source theme here. We were using the JDK at the time, and most of our customers were on the Mac. Um, and Mac OS 10 was just starting to be a thing. And I tried to implement this application, and the whole idiom of the application involved opening and closing windows. Like it was very, very windowing heavy. And the reason that I mention that is that in the JDK at the time, every time you would pop up a window and then garbage collect it, it would leak about a megabyte of memory. And a megabyte back then was a lot more than it is today. And so you could use the software, like you use the software for about 45 minutes before your computer crashed. And the way that I got into open source was two things. First of all, I kind of discovered Python around this time, and I discovered PyGTK, and I kind of wrote a custom Linux GUI app that was dozens of times faster, much more responsive than the Java version. And I got to this point where I was sort of like bugging Sun to get source licenses for the JDK so I could figure out what the heck was going on. And they were saying, no, you can't have that. Like, just use the binary. And I was like, but the binary doesn't work. I can't ship this application. I will have to re architect it from scratch, use a completely different UI idiom like, what do I do? And I got fired. Actually, that was because I had sort of predicted that this would be possible and predicated my employment there on it, and it was not possible. And so I took a couple months off and reflected on that and thought, okay, I'm not going to use a proprietary programming language for my next job. Like, I will use libraries that I have control over, so that if there is a memory leak that I desperately need to fix to ship anything, I will be able to maybe do it. And then, oddly enough, the next thing that I did, just hanging out on IRC, answering questions about Python, which I had only barely learned myself, but it was Python 152 was a lot easier to learn. Yeah, 152 was like the new stuff at the time. It was like, everybody was arguing about whether we were going to be on 1.4 for a long time. And So I was hanging out, and one of the people that showed up to ask questions worked at Electronic Arts. And I answered a bunch of their questions, and they were like, "We really need help with Python. Would you come live in Texas?" And I was like, "Okay, I guess I'm not doing anything else." So I worked on massively multiplayer games for a couple of years. I first at Electronic Arts, and that was kind of where I uh, started Twisted, because I had technically started Twisted already. Like, it was on my little intellectual property form that I filled out, like, previous inventions. But it was mostly like a art text-based RPG thing. The point where Twisted kind of got going in earnest was it was a large failing project with hundreds of engineers, and it was they were trying desperately to right the ship. And back in 2002, the thing to do was to make everybody do UML. So we all did like formal business diagrams of all the logic that we were doing. And you weren't allowed to write any code before you had a formal specification that was written out using a template. And then the template had to be specified in UML, and then the UML had to be reviewed. And then after you got the UML reviewed, you had to write a code skeleton, and the skeleton had there's all of this like process. And it wasn't like today we have code review where you like write some code and test it and then get someone to look at it to make sure that although you know it works already, it's also kind of good quality for subjective human reasons. This was just like, we're terrified that everything's going to be a huge disaster, so you can't move a muscle without 4 layers of review. And so while that was going on, I was actually implementing the chat system for the game. I went home and in my spare time wrote my own chat system, because I was like, this can't be this hard, right? Like, this is just making this hard for no reason. And I spent probably around 200 hours on the chat system at work and barely had anything working. And at home, I was done within less than a week of my spare time. Like, it was just sailed through it. So that was the genesis of, I think, Twisted Words was the first part of Twisted that really saw use, because I was using it for that. And then I went,
So can we?
yeah, yeah.
You start talking about Electronic Arts and video games, you're getting into like Jay's territory because I'm a pretty big video gamer. What particular projects were you working on at Electronic Arts?
Oh, I totally forgot. So the building didn't say Electronic Arts. The building still said Origin Systems. I was working on Ultima Online 2. Um, and that was it was a failed project. We never shipped it. But we there was I'm shocked that they never did anything with it, because like, wow, there was a lot of code there. Like, there was a lot of art assets. It was a massive expansion. It was like started development before WoW, and like we thought we were going to be going, head to head with WoW, and we thought that we weren't all going to get laid off. Um, but yeah, that was also a project where it was used lots of open source, but it was early days for like the open source development idiom. So it was a large C++ server that embedded a lot of Python. There was this notion that, like, Python started out as just a scripting language. Like, it was for the game designers to write code, because a programmer wouldn't write code in Python. Programmers wrote code in C++. And a lot of what I did at that job was eliminating entire parts of the organization by saying, couldn't that be like a 30-line Python library? Like, why are there 8 people working on this? And I probably, if we had not been laid off, I would have made many enemies because I was, 21 years old and just blundering into every room and like eliminating huge chunks of the org and causing these constant reshuffles because people would go off. Like one thing in particular was we had a C++ server that would like ferry SQL statements from like one place to another. And it was a lot of C++ because it had to do a lot of stuff to get all the strings moved around through the networking framework that we had. And I just rewrote the whole thing in Python in like 20 minutes. And then once it was in Python, you could see like, oh, you don't really need this at all. This is a library. It shouldn't be a service. And then I made it into a library in Python. And then they were like, oh, I guess we don't need this component. That was also the place I did a lot of code reloading stuff because the way the server would start up, it would start up by loading everything into core memory because there were no SSDs at the time. Everything was on spinning disks, and you needed really, really real-time responsiveness to like have a physics-based online game. And if you wanted to make a code change, it was like 45 minutes minimum because you had to wait for the whole thing to restart. And so I wrote twisted.python.rebuild was actually because of the work I was doing at Origin was just like, okay, the C++ stuff you can't change, but like if you rewrite the Python stuff, you can just call reload and it'll like reload all the code and garbage collect all the old code. And that caused a bunch of programmers to just start porting tons of logic over into Python because now they could work. And so that a lot of really fun experiences. This is also the place where I did most of the there's a big thing in C++ and it's really slow. And to optimize it, I'm going to rewrite it in Python thing to the constant incredulity of everybody I worked with. Because they would say, oh, this AI thing is really slow. We don't know how to make it faster. I'm like, well, let me try to rewrite it in Python. I would rewrite it in Python. It'd be 10 times slower. And I'd look at it in Python because now it was like 10% of the code size. You could see the quadratic algorithm now and very quickly like optimized it to be linear performance and it's hundreds of times faster. And all of the C++ programmers were constantly like, oh, that's weird. Like, I didn't think you could do that. Um,
So the
and I
really
just
cool thing about this story is is you can almost see the design molding that happened to Twisted as a result of all these things. Like sort of implicit things that I would understand is this is back when computing power was really at a premium. And so I imagine having something invented like Twisted, like that sort of design. Um, I don't know much about C or C++. I'm kind of Python born and raised a little bit ago, like sort of having gone that direction. But I would imagine there's not that much invented type of programming in the C or C++ side. Like, was there a benefit of like Twisted's design over the design of the C code, or was it simply the speed difference is what made the difference for you?
um, it would well, so I didn't actually use Twisted at work. I did use one or two modules like Twisted Python Rebuild, which had nothing to do with networking. But we had a very sophisticated C++ event-driven networking library. And it did like I learned a fair amount, not just from the stuff that they were doing at EA, but also like it was sort of loosely inspired by Ace, which I probably nobody's ever heard of Ace now. But at the time, it was a very big C++ networking thing, sort of like Twisted. But of course, it was C++, so it was really hobbled in terms of how usable it could be. Um, and uh, yeah, it was on the one hand, it was much more sophisticated than Twisted was. Like it made use of Solaris's custom epoll stuff. It had like its own thread scheduler. I think it had like a user space thread scheduler. It had its own coroutine library, which on the one hand, hypothetically, you could do a lot with it that Twisted could not do, but in practice, most of what needed doing was tons and tons and tons of game logic. They had really optimized for this world where most of the engine was this giant graphics thing. And that's not, I mean, there was plenty of graphics code, don't get me wrong. It was a team of like 20 graphics programmers, but like the amount of game code that needed to be written for an MMO at that scale was like just dwarfed all of the like engine stuff. And so it was this, it wasn't just me, like I was getting to witness this inversion on the dev team, moving from C++'s real code, or like proprietary in-house stuff is the way to go, to, oh, actually, like the open source stuff is kind of more mature than our stuff, and like the high level language is actually better for performance because we can optimize things. So the optimization was not so much like switching to an event driven model, although I did eliminate a bunch of threaded stuff also. Threading was always causing, like, at the time, OS thread schedulers were actually much worse. And so one of the things, like building all of the stacks that you would need just to have the OS threads, was like fairly time consuming. And so thread pooling was super, super important. You could not just start a thread and let it go. You had to like carefully manage them and make sure you didn't start too many, because that would kill your performance. So I did learn some stuff about pushing stuff to an evented model to try to make the best use of CPU resources, but mostly what made it more efficient to be using Python was just the algorithms in C++ took so much work to create that when you move something over into Python, you could actually see what the algorithm was and change the algorithm without scheduling a 6-month project with a 5-person team. It was just like, oh, I can see why this is like, there's 3 nested for loops, and I can just fix it. And so there was a tremendous sense culturally among game programmers at the time that everything was about micro optimization, changing everything to be like super, super finely tuned. And MMOs were starting to change that impression because the game was so big, you had to think in terms of software engineering scale. And that's where like open source started making a big difference, because they were using off the shelf components. They weren't using their own scripting language anymore. They weren't using their own like um, custom data structure library, because Python had a bunch of data structures and you could just like have a hash map that like performed reasonably well. So yeah, so lots of fun stuff at Origin. When we got laid off, I went to a consulting shop called Ningineering, and we did use Twisted there. We took all those lessons and inverted the whole structure. We built our own engine. The I'm still really proud of the naming on that. We had an engine called the Unseen engine, because the graphics engine was called Unseen. The audio engine was called Unheard because it was Ningineering. um, and those were just extension modules, and the kind of game skeleton that we built was Python. Built a lot of prototypes. We talked to publishers, but we ultimately ended up mostly kind of consulting on other games. And so I got to see a lot of code in the industry, repeat that kind of like consultant spiel of, I know you think the C++ code's really fast here, but have you considered rewriting it in the scripting language? And over and over and over again to a bunch of different companies.
Is that a problem that was unique to its time? Because like I don't know if it's personal experience or whatever. I don't feel like I've ever had that situation where I've walked into a room and been able to be like, do you want to go 10 times faster? Because in fact, it almost like, I imagine you might have gotten caught in some BS filters maybe when you come in there with that sort of promise, like a little bit of disbelief maybe.
Well, yes. I mean, no one ever believed that I could do the things that I said I could do, largely because like there are kind of inflection points in software engineering scale where like if you're writing something a certain way, there is a, or how best to put this? If you can fit an entire system in one person's head, no matter who the person is, you can make certain kinds of changes to that system that make things radically better. And the second that it requires a team of 2, it might as well be 20 people, because like if you can't keep the whole thing in your head, you have to have a meeting to change anything architectural. And the thing that I could do for a lot of these companies that we would talk to was getting their game logic or components of their system down from the scale of we have a team of 5 people all working on this together and they have to parcel out the work to one person can now fit this thing in their head. And a lot of the times it wasn't me. I wasn't the one going in and optimizing stuff. I was just like, look, let's just shrink this to the point where your game designer can put this in their head. There was also, I have to redact names to protect the guilty here, but there were, I think, even more than one company where we came in. They were doing something network because we were kind of MMO experts, and there weren't a lot of MMO experts at the time. And we were like, you have a gambling game in your game that it's like this mini game has real game consequences, or even potentially real money consequences, because people might be secretly selling their characters on the back end, and your RNG is on the client. That's a problem. And they would reply, but well, no, it's fine. The code's obfuscated. We have anti-cheat. And like, that was my introduction to information security, was because I was like a 22-year-old kid going, I don't think that's right. I think people can actually see that, and people more skilled than I would like show IDA Pro disassembler and be like, there's the next roulette wheel roll. Like, this is how any one of your users could do this, and we helped people clean up their security.
We'll have to get the other story of how you got 40 million rupees in Zelda MMO at some other day. Then,
Yeah,
so
I honestly never really weaponized my skills. I had several friends who did have interesting security research in games stories, but yeah, mostly I was just sort of tediously telling people, no, you really need to put the RNG on the server. So yeah, from there I went to DivMod, which was an email startup. Did a lot more enterprise stuff. Um, and that was like 10 years of email. We used Twisted. We wrote a whole bunch of custom open source libraries. It was a real blast, but honestly, there's less to talk about there because it was just mostly like we were competing with Gmail. We had no hope. We were just trying to replicate, like, we actually, I think, beat Gmail to shipping by about 6 months. But once it became clear that we were playing in the same sandbox as Google, it was kind of all over, and we didn't know it for a long time. We built a lot of like that. That was my introduction to something that you probably heard me talk about at Rackspace quite a bit, which was my obsession with operational simplicity, because we just couldn't afford to hire ops people at all. And so all of our systems were these monolithic servers that you would start up, and all of the configuration was in the database, and everything was set up so that if there was an operational problem, it would either self-heal or crash. Like, there was no like operational stuff that you would do to kind of fiddle it back into a working configuration. In particular, we had a rule that there was like one cron job that was allowed, and that was just like a watchdog thing. Everything else was internal to the service. It had its own scheduler. It had its own database backed queue. It was just like 100% in process, so that you could, so that any operational problem that we encountered, we would either simplify or we would write self-healing code around. And that was the way that we built pretty much everything.
it's interesting to have that context because as someone who was an operator having conversations with you about these ideas, it sort of internal screaming occurred a little bit because there's definitely a lot, and this is sort of a theme a little bit of that, like, you're not afraid to reinvent the wheel. And the thing that's got to be really frustrating as the guy on the other side of the conversation is that it did come out a little bit rounder every time, which is, and even when you say that, like, you're espousing some of the benefits of systems that are just now sort of coming to maturity now, like we're talking about Kubernetes and things like that. So it's
Yeah, and it's interesting how I had the right idea in many ways. Like, there's a lot of stuff. I mean, at the time, during the DivMod era, I was doing a lot of upstream development with Twisted. We even did a bunch of consulting work, like open source consulting work. to just to maintain Twisted, like the foundation would pay us, and we had a whole arm's length kind of contractor bid thing so that we were not unduly compensated. Honestly, we were probably massively underpaid, but like, so we very carefully set that up. But one of the things that I spent a huge amount of time advocating for, probably twice as much arguing about this than as arguing about event-driven networking instead of threads, was you should have code reviews. That was hugely controversial at the time. The idea that an open source project would reject a patch if it wasn't tested or if nobody could code review it, like, one of the comments I got many times was, you guys are stricter than Linux. Which makes no sense. You're not as complex a project as Linux. Like, there's no reason, and nobody else does code review like this. You shouldn't have tests. You shouldn't have code review. You're just slowing everything down. And we had like a process consulting business where we would come, and we called it the Ultimate Quality Development System, UQDS, and we would come in and teach startups how to do it, and like, got a lot of pushback sometimes from internal employees. We got a lot of nasty email from open source contributors. And now it's just like all of the stuff that we had to write white papers about and give hour-long presentations at conferences. It's just the way that everybody does everything now. So like, that stuff we nailed. But on the operational front, like, we didn't ever get to a high enough scale where we started to see some of the stuff that, for example, like the control loop stuff in Kubernetes, we had no idea that you needed something like that. And we never got to the scale where we would have fallen over. And so some of the architectural decisions that we made were quite bad and would have gone horribly wrong if it had been a higher scale service. But a lot of the stuff that we did also, like, our goal was always to obviate categories of admin work, right? Like, so cron jobs are the easiest to explain because every large service, particularly like every mid 2000s service, had just an army of cron jobs that were constantly needing to be like manually reconfigured, and software updates need to be applied like across the whole like fleet of servers. And sometimes one machine would have a problem and somebody would have to SSH in and like fix it up. And we had this thing where it was like, no, all of the timed tasks that go into this application are in a database that you can query. That has nothing to do with cron. The only thing that cron does is like be an external process that isn't part of our main thing that can ping it and like email us if they like alerts and stuff. And that design idiom, I feel like, has made its way into a lot of operational systems, but like not all the way. There's still a lot of heavy operational faffing around that goes into like a lot of larger systems until you get to like, actually Google or Amazon scale, where you can't have that anymore, because if you did, like, the system would just fall over because having human intervention
Well, it's
would change
interesting
it.
because as you told that story, I kept thinking about like in OpenStack, we have those. We have periodic tasks. We have the exact thing that you lay out, where if the application needs a cron job, we don't go like shake hands with the cron or with @d or with systemd to have it run. It runs on its own timer. But that definitely comes with some drawbacks. Like I definitely remember operationally for On Metal, we kept having a recurring problem where um, if there was an error, either a raised exception or the fun part, we would get segmentation faults sometimes in Python. In the thread that was running the periodic task, the task would die, the thread would go away, but like you would sort of lose, like there wasn't that sort of back end piece of tracking. And sort of as someone with more of an ops background, I hear that and I sort of think about, and it makes me wonder again, like how many wheels have we reinvented of like having the external services? But then I think back, it's like I sort of oscillate. It's like at the beginning, it's like there's all these lessons we could have learned, and then it's like I understand why. Now I'm kind of coming back a little bit because no matter how hard you work, you're gonna need that like Kubernetes operator to install your project or an Ansible module or something. And it, so like, is that still like if you were starting from scratch today, if Glyph's building an internet service from scratch today, do you keep that same sort of strong disposable server? Application manages itself. The only thing external to it is a watchdog, or would you take maybe more of like a little bit from here, a little bit from here? Like how has that evolved over time?
So in general, I throughout my career I have pushed more and more in that self-contained direction. And this is one of the reasons I was like pushing super hard. Like you can see on my blog, I have a bunch of articles about like deploying Python in Docker. I have well, I should give a little context. I started the story when I got my first job, but my dad worked in software since the mid 70s. And in fact, he recently told some stories. I don't know if I could repeat them, but he did uh, operational software for copper refineries, for nuclear power plants. He was like doing some pretty serious like orchestration stuff. It was mostly about business decision support stuff, but like for example, his company had a product that would do parts and repair inventory for nuclear reactors. And so, because when you shut down a nuclear reactor, you really want to get as much maintenance done as you can because you don't want to turn it off again. Like you really, and they wrote software that would save some number of millions of dollars in early 1980s money. That just because you couldn't keep track of it on paper. And he went on to build kind of one of the earliest email systems, and he actually built a framework that, from what I have heard from people that both he and I have worked with, was quite like Twisted on a Stratus mainframe. It's this Motorola 68,000 series chip that was like the new hot thing at the time was C. Instead of writing all your stuff in like PL1 or assembler for the mainframe, you would like do it in this high level language. uh, and he had that same sort of thing. You wrote this framework uh, in C that was event driven, that used like sockets and TCP/IP, and like was very forward looking for the late 80s. Um, and one of the things that he used to do with his, because he became a manager and he would have teams, and he would watch the Terminator with his teams, and as part of like a sort of team building activity. And he would point out at the end, he would say, uh, your software should be like the Terminator. It should just at every point, if you blow its legs off, it should crawl. If you, break its fingers, it should pull itself along by its arm. It should just keep going towards its objective until it can't anymore. And to make this point, he would go into the server room and kick the plug out of the wall at intermittent intervals at a time when the way that you did reliability was like quad redundant power supplies that would never ever drop power to your system. Because his thing was like, well, we had a power outage once and it died, so like the software better be able to relaunch itself. And so I kind of grew up on these stories of dealing with like of thinking about software as like it's an autonomous agent. It should be autonomous. It should do the thing that we have designed it to do with no human intervention until we want to change its state, right? If we want to tell it to do something different, then we tell it to do something different. But just like being on and running should not be a thing that we need to tell it to do. So self-contained tasks, self-contained, like build your software into a single artifact that you can ship to a machine so that if you need to replace it, you just replace the artifact. You don't like install a bunch of packages and like try to, manage the dependencies in the operating system. You just like ship the artifact as self-contained as possible. The thing that I would change if I were architecting some of these systems nowadays is I would use process boundaries way more. I would have there be kind of an Erlang style ultimate supervisor that itself had no sockets open ever. And then I would have that system spawn everything else that needed to run, and never and like the thing that's in charge of everything keeping running would have like one job. And one of the we never really, again, we didn't get to a scale where we got to see this kind of in anger, but one of the things that we started to realize about our architecture at DivMod was that the controller service, the thing that would start up, kind of had all the logic in it. And like we were really hardcore about writing lots of unit tests and considering edge cases and fixing every 500 the second that we saw it in production. And so like it was pretty robust as a service, but if we wanted to get to the point where the servers were running hot and 100% CPU all the time, we would have needed to break it down into like more sub processes to take advantage of multiple CPUs. Also is kind of a nice side benefit, but also for the reliability of like put the networking in one process, put the control in another process, put the logic in a third process. Those things should all be kind of like at arm's length from each other. And so yeah, so I think that part of my architectural impulse has changed. But like at Pilot, when I set up their infrastructure, like I was, employee number 3. We didn't even have a internet service when I started. It was all command line tools, and I helped build up the very first deployment. Kind of did the same thing there. We just put everything into a Docker container, and every time we were like, should we have a second service? I was like, could we put it into one Docker container? Is there any reason we can't just be init and spawn all the processes ourselves? And they now have a much more traditional cloud architecture, but for a long time we kept with that style because, and this is the kind of the point that I've been building to over this whole Shaggy Dog story, if you build your system as a single artifact, your automated tests can cover all of it. And the second that you step into the world where it's like, yeah, well, it's mostly here, but there's like a little piece that lives in cron, now you have to think about how to simulate the cron environment. How do you test the code that runs there? How is it different than the code that runs in your main process? Whereas if everything is just like one code base, but processes that have different roles that are getting sort of spawned by this controller process, it's very easy to simulate that environment because you just got the one environment, and then everything that you spawn, you fully control what's happening there. And in more of a traditional cloud infrastructure where you've got like a Kubernetes or a, EKS or some kind of, or a cloud formation, like once you start having like more infrastructure, it's harder to enforce that development to production correspondence. Eventually you have to, because like you need to have multiple services, you need the resiliency, you need the elasticity. Like there's all kinds of good reasons why this architecture cannot scale forever. But at almost every point where you think you need to start using a ton of off-the-shelf stuff and shoving everything into Kafka or whatever, like you probably could just keep it like a little more self-contained. And even when you do start having multiple services, you can probably still have one code base for a really long time. You can probably still have one environment and just a small amount of configuration that changes what happens when your different services start up. I was also very big at Pilot on like, we're going to do one service. It's going to be a monolith. If we have to do microservices, if we're going to do more than one service at a time, they're all going to be Python. We're going to use the same stack everywhere because like we don't have the resources to maintain the platform technology for 5 or 6 languages. And that's the reason that I kind of chafe a little bit at the Kubernetes world, because once you start thinking, oh, we can have microservices for everything, it'll be managed for us by our orchestration layer, there's this temptation to be like, oh, and we could write a couple things in Rust and a few things in Erlang and some things in Haskell, and now you're out of business because nobody knows all that stuff, and the one guy who liked it left.
Well, so there's, first of all, I feel like that the big lesson from all of that is that if you're watching this on the VOD, pause and start looking for the latest quantum programming breakthrough on the children's drawings on the back wall. Because of like Glyph's dad designed Twisted, and like Glyph designed, Kubernetes adjacent DevOps ideas, and those are pretty fresh. Like, what is your kid gonna come up with? That's what I'm waiting on, is like they're gonna be like, Dada, crayon going. Start taking notes. That's what I'm saying. So,
Yeah, when I was her age, I was mostly building text adventures. So I don't know if the hints are already there, but um, sorry, I forgot to mention the thing between um, in the late part of DivMod. One of the projects that I got to exercise this architectural style on was bus radio, which was a radio that went in school buses. And uh, there we wanted to use Python because we all do Python. And one of the concerns was they said, no, you have to use C because there's not enough memory on these boards. They're these tiny little, single board computers in this one in 2006. They're tiny little single board computers in 2006. There's no way that you're going to be able to run Python. And so we said, well, what if Python was init? And so you didn't load any other C executables on the entire machine. You just like mapped your first the Python executable, and then it would be init and it would spawn sub processes, mostly just forking, like it would mostly just fork and then do something else without execing, which on a computer where there was two processes you could do relatively safely. And we got some very impressive reliability out of that because there was literally no C code running on the machine. It would boot straight into Twisted, and the application could be tested in a development environment because, like, you were just spawning processes and you didn't have to, like, there was a little, the hardest part about that project was we had to do that extra thing that PID1 has to do with SIGChild that no other process has to do. But other than that, it was all testable in a test environment, which was pretty important because one of the things that the reason we were using Python for this was it had to self-update. And when you have like 500 buses in a garage, all of them needing to self-update, and there's a bug, you're in a bad place. And in fact, we were so worried. We tested this so extensively. It was like one of the first projects where we had 100% code coverage rule, and we tested code coverage everywhere. And then we shipped it to the buses, and we did have a bug. And the bug was we didn't put any jitter into the update process, and nobody had told us it was going to be updating when the buses were off. So we actually bricked an entire fleet of school buses. There was a day off of school in Western Massachusetts that was my fault because the buses would all wake up, they would all connect to the local Wi-Fi, 100 buses or something in this garage, and then the Wi-Fi access point was rated for like 6 devices. It was like a consumer home router, and they would all interfere with each other and die, like, because they would retry until they couldn't retry anymore, and nobody would get the update. And because nobody got the update, they would just keep trying like the Terminator. But the problem is they were consuming battery off of the car battery the whole time. The devices did not have batteries in them. It was wired straight into the dash. And so every bus, like, so the CEO of the company that had subcontracted to us, my friend Rafi Krikorian, had to grab jumper cables and go and jump every single bus that had one of these things installed in it. It was amazing. It was, and the only fix was we added a little bit of jitter and exponential back off, and then it worked perfectly from then on, and not a single other bug report.
so I'm sure those kids love you for that one. Uh, Yeah, yeah. D Reed is in our chat here, and he chimes in that good thing everyone learned not to do OTA updates in automobiles. That's if you ever wonder if you're sitting at home and you're watching this and you're not a technical person, I'm sorry, but just this is the reason why like no one wants their oven to have a Wi-Fi chip in it. Like this is the whole thing because even when you do it well, like there's always stuff that people didn't think about. And like in something that I find interesting and like a lesson I kind of pulled from that bus story, and I'm not sure I pulled it the first time because I've heard that one before now, is that you can test one thing in a dev environment all you want, but you can't escape scale. Even in real life, like the real life constraints of scale are gonna come and they'll come home to roost a little bit. That's interesting. But we're kind of closing in on the last 15 minutes. So I sort of wanted to shift from the history to kind of to the present. Because I think we have something a little bit in common. Because I work on OpenStack. I'm a technical committee member, PTL of Ironic, um, partially because of your help learning Python. So I'm just gonna go ahead and blame all the minus ones I've ever gotten on patches on you. So thanks for that, Glyph. But but Twisted is a useful piece of software. It's still there. It's still a great library. It's got a good buffet of options to pick from. And it's like a reasonable technical choice in many cases, but it's not the attractive one in a lot of cases. And I think that has a lot of parallels to OpenStack, where OpenStack is used by a lot of people to do real work. It can do a lot of stuff. It's got the full buffet of options that you would want, but not a lot of people are thinking positively about it because it runs quietly in a lot of places and there aren't any cool 21-year-olds streaming into game studios telling them that it's better than C anymore. So like I kind of wonder like what's the state of Twisted now, and like have you thought about, do you even care about if it gets more adoption, or sort of do you think there are maybe lessons you've learned in sort of working on this mature enterprise level project for a while that's sort of grown to that point that might be applicable to OpenStack, which is, I mean, we're a few years behind, but I definitely think we're in the same sort of trajectory.
Yeah, I mean, I don't know how much of this transfers to OpenStack, but I could maybe it does. I think that the one of the things that has enabled Twisted to have some staying power is that we have not ever completely lost track of the need to scale down. And this is one of the things that can be really tricky attracting contributors, right? Everybody always wants to scale up. It's really attractive to talk about like Netflix is using your thing and Apple's using your thing, and people are, it's like millions of computers or whatever. But there is a bootstrapping problem, which is you need new contributors to like help you continue to maintain it. And Twisted does have a fair amount of difficulty with that because a lot of it's kind of obscure protocol stuff. A lot of it is like not immediately obvious what you need it for. It's a lot of its layers of the stack, which have been subsumed by service providers. Like it's got a pretty reasonable DNS server that needs some updates. Not a lot of people want to run their own DNS anymore. Like if you need to, it's a great option. But probably you could just put it on Route 53 and call it a day, right? Like there's a lot of other options, which is imagine that's something that OpenStack faces as well, right? Like
You would run it.
while
You would run designate, I think is what you meant to say there, right? You would run OpenStack
right.
designate for your DNS.
um, and so I think that to the I plan to continue using Twisted. It's actually being used in some of the desktop apps that I'm working on. Like it's just the event loop that I'm using because Twisted has reasonably good support for desktop operating systems and GUIs. Um, and it's just familiar, and there's a lot of utility code in there that I just know how to use. So that's a good way to kind of keep the tool sharp. But I think that the to the extent that Twisted will do well or poorly, there's a lot of discourse around like, is it really the best option? Should you use async IO? Like what's its purpose? How does it need to be branded? And I think that that is somewhat missing the point. And the being the cool, sexy new thing is always helpful, of course. But the way that you really maintain a solid contributor base is you have a path into the project and a user profile for whom it makes sense to contribute something. And that means that you probably have to have something that an individual can do with it. And if not an individual, then a small startup team, because individuals and small startup teams can choose their technology and can like choose to adopt your thing even if it's a little bit weird, if it does something cool that they like or that can have influence over its roadmap. Whereas people at larger companies you're really at the whim of like whatever they've been using for a while, and you tend, if you're the legacy option, if you're the more mature technology, you're typically just kind of losing users by default all the time because people are just migrating to other stuff to try things out. And when a big company does that migration to something else, it's probably for 5 to 10 years, and so you can't necessarily depend on those users. You have to have contribution options for smaller teams and smaller groups. And I did always like, I think that this is one of the issues that OpenStack has kind of been plagued by, is that the overhead to get into the bottom of OpenStack is quite high. And the irony is, it's actually also one of the things that makes OpenStack still relevant is it's high, but it's like lower than getting your own custom like Oracle cloud, right? Like you can do it with a plausible amount of hardware. If you have some reason that you need a small private cloud, OpenStack can do that for you. And so I think that that is where a lot of the interest still comes from, is the fact that you can do that. But I think it would probably be even more successful if there were like, if you could, for example, just push a button and have like a full kind of simulated OpenStack cloud just run on your MacBook for backend development. Like, that would, people would love that. They would, oh, I don't have to set up my whole Kubernetes thing by myself. I just have like a cloud locally, even if it was, kind of a bunch of dummy drivers and stuff. And yeah, so I feel like that's what I want to do for Twisted, is I want to continue focusing on scaling it down and making sure that it works for people who are just starting projects. And to some extent that's working. We do scale down quite nicely. The twist command line that like starts a server for you, I still, at least once or twice a week, will do twist web dash dash path and then some file directory that like slurp files across the network in some ad hoc way. Not every device supports AirDrop, so there little tools like that that people can just use for day to day stuff are super helpful for getting contributors.
It's you've done a really good job of hitting us where it hurts a little bit and drawing a really stark contrast, because that is definitely true. And I think about a lot of people like to compare OpenStack and Kubernetes. I don't think that makes sense. I think they're like different layers in the stack. But in terms of what you're talking about, there are a lot of stark contrasts, because you have lots of projects out there like something like Kind, which is like press a button, receive essentially a full Kubernetes cluster on your device. Containers are inherently understandable to people because they've run software in a container on their machine before, so it's like a little bit easier to understand. But with OpenStack, there really aren't home use cases for OpenStack. I mean, I'm on the technical committee. I was gonna say a sizable home lab. I'm sure there are bigger ones than this, but I mean, who has a home lab? So even having ones there, and I don't run any OpenStack services because it doesn't really make sense at this scale. And so like I'm really gonna ponder that, because it's a very, very good point. OpenStack doesn't serve that community at all right now. In fact, quite frankly, it can be difficult for a new contributor to get a dev stack running on a dedicated VM, much less trying to just do a little bit of stuff for devs. So I think that's hitting the nail a little bit on the head, because you definitely see it's man, it really is. It's sort of self-fulfilling in a lot of ways, because you go out and I've worked in tech SaaS too long. Like, they always call them logos. Like, you go out and you get the big logos to put on the web page, and they feed back contributor support. But there's no one here. There's no one in OpenStack at all saying, what about the use case of, Bobby has a really beefy server in his basement and he wants to run, just OpenStack in a box on it. That's not, I don't think it's something that necessarily, even as a project, we've wanted to do. But you're exactly right. If that's why, like, people wouldn't want to go do a drive-by contribution. Everyone who contributes to OpenStack is expecting to get something immediately back out of it, other than them running the software. Either someone doing an internship and getting paid for it, or trying to build up experience, hardware vendors who are contributing, or even, those hyperscale customers themselves contributing back resources. So that is, man, that is nail on the head. I don't know how to solve it. That's a
Well,
whole different. That's another 1 hour conversation probably, but that was really useful. But before we get too far, we've got about 5 minutes left, and I'm happy to keep chatting past time. And if there are questions in chat, you can toss them out. But I did want to make sure we had a chance before the hour's up to plug anything as necessary. I'll say like I always say, thanks to G Research for paying me to work on open source software, giving me this opportunity to share some of the knowledge, and in this case, getting to sort of take a person who helped me get on my open source journey, you know, tell some of his story to you. And what about you, Glyph? What are you up to these days?
well, um, I took a break mid-pandemic, and I am now kind of getting back into the swing of things. And I am I guess, a tech influencer now. I have a Patreon. I'm just getting it started. It's at patreon.com/creatorglyph. You can visit my blog at blog.glyph.im, which has links to various things around the internet. And yeah, I am. We didn't get to talk about Pomodoroboros at all today. I do have a few more things to say about uh, the scaling down conversation. We can go into bonus overtime, but I'm my primary focus right now is actually on a couple of apps to do some information security stuff, which hopefully I'll be announcing next week sometime. And the other one is a Pomodoro timer, which is an ADHD kind of intervention. It's like very much geared towards. I have ADHD, and it's geared towards helping people with time blindness, which is one of the less well understood symptoms. Just kind of like helping you keep track of your day in a way which is friendly to people who are going to forget to start a timer. And so that actually uses Twisted. It uses Twisted's time APIs and uses PyObjective C on the Mac right now. There will hopefully be a Linux version at some point and a CLI version for people who don't want to set up an app. And so yeah, so I'm working on like small independent projects that use a lot of open source software, maintaining the open source software along with it, writing about that sort of thing. I do a lot of blogging and trying to get people to just support that in general, because there seem to be a lot of people who like my ideas and want to hear what I have to say. So yeah, so that's what I'm doing.
Yeah, that's excellent. I mean, we'll keep talking. I mean, I feel like Glyph and I could talk for probably hours and hours about tech stuff with no time. But I'm curious to hear what further you had to say about the scaling down topic, because that was one that that's so insightful, and that's such a good way to put it. And quite frankly, Ironic's done that some, even if OpenStack hasn't. Right? Actually, I'm gonna say that, and then I'll let you go. One of the things I'm really excited about in the Ironic community is actually a place where we're crossing over Kubernetes a little bit for a product. Metal 3, Metal Cubed. I don't know what people say when they say it out loud. We're in a pandemic world. How many times do you hear text words said? But it's metal3.io. But the idea is that's it runs basically an ephemeral Ironic to load in a bunch of your equipment servers, which are provisioned by Ironic and fed into Kubernetes through this Metal 3 project, and then it shuts down. It's just running Ironic against SQLite, just real small. And obviously that means you're limited to like the max size of a Kubernetes cluster, which is like 5,000 nodes, I think, or so is what they tell people. Even though I definitely know it'll scale a little bit past that. It's interesting because that is where a lot of the interest can be in Ironics, especially. And it never occurred to me that that's sort of a form of scaling down, right? Like it's backgrounding a little bit of the work that OpenStack is doing. It's making it so that people aren't thinking about it. And I mean, quite frankly, you should love the entire idea of like an OpenStack service being spun up with all its config in another service and like taking care of its care and feeding it. I didn't even realize till I got halfway through that it sort of is almost a variant of the operational philosophy you've been espousing.
Yeah, I mean that is interesting, and I think that it's so. Let me go back to history for just a minute first. Long before pip or easy install or anything else, one of the things that Twisted did, which helped it really blow up in its early life, was we would do releases, and when we would do a release, because the source release back in the day was like much more of a ceremony, I would kind of deploy to a test site, and then I would count the clicks that I had to do in order to get it installed, and like time to first bite, basically, for the person to like have Twisted running and print anything on their console. And when people would add stuff that would make there be more clicks, I would like prune it back and try to keep it at this like absolutely minimal installable state. Because once you, and this, we kind of, at the time, the big kind of behemoth was Zope, right? Like Zope was really big and took a lot of setup. And nowadays, I think, especially with modern dependency management, it really wouldn't. But that we thought of it as very heavy because you had to download all these different things manually. And it was well factored. It was like there was a good reason you had to download it all separately, but that really impeded a lot of its adoption when it crossed that threshold into, well, there are 9 dependencies, why not have 10? Once you get to that point where it's like, well, you already need a custom VM to run anything in OpenStack, so why not add another config file? Why not add like, just a little more stuff? It's fine. People are going to be sitting down for an hour to set up their dev environment for the first time. What's 5 more minutes? And soon it's 10 hours, right? Like soon you've just like blown through all these time budgets. Um, and so I think the having that constituency, like once you have the people involved and contributing who care about setting up things that scale down, small scale stuff, once those people are involved, they'll keep exerting back pressure. They will notice when things take 10 more minutes to set up, and they will say, hang on, this is like a bug. We should not add this to the minimal configuration path. We should make sure that this is automatic. Whereas on the flip side, if you once you have lost those people, you will drift ever further away. Everything will keep decaying because you're not setting budgets anymore. And either you need a formal budget that's like it can't take more than this much RAM, more than this much CPU, more than this much disk to set up a cluster, more than this many config files or this much time, or you need somebody who like cares about it and will exert an informal backward pressure. And once you have neither of those things, it can be very difficult to claw your way back. And the thing I would say is it's worth making it an explicit goal to claw your way back, because once you've done it, once you've got that minimal thing, it'll take a couple months before your first contributor shows up. But once they're there, now you don't have to maintain that pressure anymore. Now you can go back to the thing you actually care about for your job and let the other folks come in. Like, for example, if you had something for Ironic that could provision Raspberry Pis out of a home lab, right? Like that may be an unrealistic goal. I don't know enough about how bare metal provisioning works, but like,
Raspberry Pis don't like net booting very much, as I understand it. You basically have to install an OS that knows how to net boot that will install your OSs alongside it.
maybe the thing to do then is to ship an SD card image. I don't know. Like there are, if you can ship a ready-made configuration for people to do those kinds of projects with, I bet that you will, within a couple of months, you will get people showing up that will breathe new life into the development community for that project. And it may be DNS. You might be able to like run designate as your internal home DNS server. These use cases may not be the right kind of scaling down for OpenStack. Maybe the right kind of scaling down is just like thinking about a startup dev team with like 5 people, and just like, what does that look like, instead of a home lab, which is really like micro scaling down. But yeah, so it depends who that constituency is, but you want somebody from that onboarding part of your journey, not from the big logos like enterprise use case. Because, and this is one of my favorite business stories, Apple versus BlackBerry, right? Like BlackBerry was actually absolutely had a lock on the enterprise market for a long time, but they decided that the thing to do was add more enterprise features, go up market, get everything to be bigger and more enterprisey and less usable as an individual. Whereas Apple was like, who cares? We don't even support MDM. Like, if you want email, it's got to be like POP or something, right? Like, we don't care. But because Apple addressed that entry level consumer, they kind of cut off the oxygen supply to BlackBerry. There was nobody who was going out and buying Blackberries for fun to try them out. And suddenly Apple is this juggernaut, and Apple never lost touch with the bottom of the market, right? Like they're certainly not beating Android in that sector, but there's always something. There's always the SE phone. There's always the really low end watch, right? Like they'll always have some product to get people in at the bottom.
Even to the point where I know some Android users who are jealous of the fact the SE phone exists because of its price point and its size, and you can't get stuff like that. The interesting thing is, I think, taking off my general OpenStack hat, I think for OpenStack as a whole, that's almost too big of a thing to take a bite of, because OpenStack almost as a stated goal is sort of against the direction you're talking about, right? Like OpenStack these are these separate programs that usually are useful on their own, but when they come together, they provide like a uniform service thing. With Ironic, we've definitely taken hold, I would say, over the last 4 or 5 years of focus on what we call standalone Ironic. And it's not the best name, because when we say standalone Ironic, we don't necessarily mean just Ironic and nothing else. We often mean Ironic to do bare metal provisioning plus the minimal set of services you need to support Ironic. Like for some people, that might be a Neutron if they need to do networking, or a Glance if they want more advanced image management or that sort of thing. And we've had some projects come out of that which have gained a little bit of traction, which I'll name check here. There's Bifrost, which is basically a collection of Ansible modules that spin up an Ironic cluster and help you manage it to manage machines. And I know of people who've done USB key style provisioning using Bifrost, where you have, a rack of new servers you're about to roll into a data center. You plug in the USB key to one of them, you run Bifrost, and all of them will get inspected, provisioned, whatever, and kicked in, which is pretty cool. And like I said, the Metal 3 integration, which takes a very similar view of using Ironic, because and I've said this to folks before, that the tricky thing about Ironic is that the things we're good at is the things that most people don't think about. It's the fact that you've got folks who've been working on it for a decade. You can go look through the IPMI code and read a giant comment about special models of super micro servers which need a special set of raw bytes sent to them, and all sorts of that stuff, where like in the real world, Ironic has sort of lined up against these APIs, and we figured out the places you have to adjust to make stuff work. And fun enough, those API badnesses continue. There was a new release of a DRAC firmware. If you're running Ironic out there in the world, do not upgrade your DRAC to 6.10. We have smart people working on it, but even better would be if people followed the Redfish specification to the letter, and if they made the specification specific enough that there weren't like 10 different things, even though it's supposed to be the same API. That'd be great. But like it's, I like thinking about, when I think of scaling down for Ironic, though, I think about what are ways that we can get access to that knowledge that's encoded in there. Those failure cases, the interactions with hardware, the interactions with Anaconda for the Anaconda driver, these sort of pieces which are where the actual useful bits are, right? Like you and I know that pixie booting a server is not magic, right? Like the stuff that makes Ironic special is the ability to do it for any set of reasonably modern hardware. So like, I think scaling down for Ironic, the thing that I'll take is your advice, and like apply it to sort of thinking about Ironic as standalone of, are there other ways that we can expose that value downstream? Which is kind of interesting to think about. Almost makes me wonder about if there's a world where you could have an Ironic CLI client that is not an Ironic CLI client. It's not talking to an API on a server somewhere, but maybe where you feed it the username and password, and just, you're actually calling the methods in Conductor that would go talk to that IP address and do the thing. And then that way you can have a power on, power. I don't know. That's probably not that useful to people either. I don't know, but this is sort of the direction I think you're sort of pointing me at, which is, this is the special bit. I need to make this special bit as accessible to as many people as possible, because it's the most interesting thing in the project, realistically, right? The rest of it's going to be sort of rote. And B, those are things that are accessible to people. If you can give that to someone so that they can boot a thing in their home lab, or even make it where, like, I'm going to tell you that this is great. We actually have emulators in our CI that you can talk to them using SNMP as if they were a PDU, or IPMI as if they were a BMC, or Redfish as if they were a BMC, and it translates it into libvirt commands on the other side. So you can actually manage your VMs as if they were server. Like, stuff like that is really cool. It's fun to play with. I have no idea or no real strategy as to how to use that as a hook to get people in, because I've been working for 10 years on being paid to make server provisioning happen. If there's ever a person in the world who's not going to be like, you know what I'm going to do on my own time, work on server provisioning software, that's not me. So like, I don't necessarily know how to reach those people, but I imagine that's got to be somewhere in there, right?
Yeah, so one way to think about it, instead of trying to reach super far outside your own experience, it might be something more like when you notice something, right? Like if you've got some BMC command you want to issue, right? If you've got something that you're like, oh, there's this code in Ironic, I want to get access to it. I that CLI that you mentioned, like I only have the vaguest idea of the kinds of operational things that you can do with it, but you obviously know exactly what those things are. And anytime you notice, like, hey, this would be useful, I could really use this in my day-to-day testing, in my home lab, whatever, or even just at work on some test rack, right, where you're doing something to set up development, whenever it occurs to you, like, I could write a tool that would do this, put a pin in that and think about that as a use case, because really the way that this type of scaling down typically happens is you make something that's useful for you, and then somebody else comes along and goes, that's almost useful for me, but here's like a contribution that will make it actually kind of fleshed out for this other use case. Trying to press all the way into like fully supporting this whole use case that you don't really have or understand is never going to be super successful. But like you said, exposing the parts of it that are useful in like in Twisted, I know you got to go in a minute, so I'll try to keep this quick. But like in Twisted, the equivalent to that is like we've got a really robust sub-process management API, which I know from experience is like a bit more reliable than the one in the standard lib and has seen a lot of like battle hardened use and testing. And we one of the projects that I would love to do in the next year is like a supervisor service that uses Twisted, that just like does kind of watchdog stuff out of the box. Because right now setting that up involves writing a ton of Python code, and you shouldn't have to do that. Like it should be the sort of thing that all of the stuff that you need to do to orchestrate it together is like very rote and not very interesting, but it's not bundled into the project. And so people who need that kind of thing just go use supervisor D. Like they wouldn't think to use Twisted for it, even if
Or System D, really. System D does all that stuff. You don't need Supervisor D anymore because System D will do it, but you get that same problem we talked about earlier where like it's almost like the more information you have to communicate into the operating system about your application, the more overhead you have. Oh, I was going to say this earlier. The thing that I love about your self-contained container application is portability. It's not about like portability in terms of like computers. Let's imagine a portability as in like you don't have to run in US East 1 like half of the freaking internet does. And oh man, that was my biggest frustration when I first got into cloud. Is I had a few friends who were doing startups. One of them gave me a call and was like, I'm doing a startup. I need advice on how to do infrastructure. And I'm like, make sure that your cloud-based infrastructure needs remain generic enough that you can use a library like Fog, which will abstract it, that you can point to another vendor. The second you think you need something that's like AWS specific or Google Cloud specific or Rackspace Cloud specific, you need to stop and solve that problem in another way in order to be able to port your product between all that. And no one wants to hear that. No one wants to hear that at all because you basically took away their magic. And so like that I always struggle with that a lot when people would ask me about opinions and setting up stuff. And I love the idea of the self-contained container, because telling someone to stuff all your stuff in a container, they hear that as like a positive thing, but really they're getting a lot of that benefits. You can even nowadays, you're not even tying yourself to Docker because there are so many different container runtimes you can do that all accept an open format. It's sort of a, man, this really is a like a great example of the bazaar in some ways, right?
Well, it sounds like we've got a ready-made topic for another stream some other day. So perhaps I will set one up and have you as a guest on mine at some point.
Hey, I really do appreciate you coming here and talking. And you were asking me a little bit about setup when we were coming up into this. So I'll cover this if you're not interested in the meta stuff. Thanks for tuning in. Uh, I mean, I think the production quality on this is okay. It's not the best. I had a new problem here today, which is I was having to frantically mute because I was getting echoes to myself, which I should have been a little more aware of. This is the first time I've had to be able to hear the sound coming out of my desktop and stream at the same time. But the setup is pretty reasonable. I've got a blue microphone just right here in front of me for the microphone. Yeah, see, I have the arm for it, but the arm last thing I need is something swivel that like I can whack into something. That's not for me.
I definitely hit it at least twice. I find though, for at least for my desk, like I needed the shock mount. Otherwise, every time I would like press a key or click a button on my mouse, it would just be like boom, 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 boom. So like, I think if you have a softer wood, it might not be quite so bad.
I have a desk pad. The desk pads are very helpful for that. But for camera, I actually use Droid Cam. I literally went on Swappa and bought like a Pixel 3 from several years ago for like $100, and I have it over Droid Cam. It's mounted on like some $30 tripod I got off of Amazon. It's pretty clear I need to work on lighting. I was telling you before that, usually there's a little corner in the bottom. You can't tell that I'm badly lit, but the rest of it is just wrangling with OBS. I picked YouTube as a venue for this because I think it's a little bit easier to move into. Really want to move into a sort of place where I might be generating more than just the live content, and this is good for it. Also, I already do stream video games sometimes on Twitch, and I decided to keep those sort of separate because I may not say polite things to the person that I'm like shooting in the face in my first person shooter game. So I mean, there's not a lot of magic. I have a capture card I use when I do the live coding sort of things that comes off of my laptop. That's really the advice I would give is do the two computer thing if you want to share your screen. Your Macs, you're probably going to be better supported. I'm doing all of this on Linux. Well, I'm lying. I'm actually on Windows right now because this is my streaming computer is dual boot and often runs Windows. But I usually do this from Linux, so it can be a little bit of a pain. But I mean, the advice I would give is just do it. Like in the reality, like when I think about blog posts you've written and stuff, I would go read them out of a gist. I don't care where they're at, right? Like it's sort of the same idea as like you've got stuff in your brain that I think people want to hear about. I mean, like I said, we talked here for like an hour about, I feel like nothing. Like I had notes and I maybe got to like the first thing in my notes at all because it's fun to talk about the past and how the past impacts the future. And like you're a good person to do that, I think, for folks of sort of our generation ish. So I mean, I just do it. Like go live and do it. You don't even need OBS if you're doing YouTube and you're just sharing screen and a webcam. I think it'll do it out of the web browser, and you don't even have to fight with OBS.
Oh wow, I might, yeah, that might be a good. I mean, in the spirit of the my Patreon launch, I was trying to launch the Patreon page for like a year, and I just was writing this incredibly huge, like, very detailed pitch for everything that I could possibly do and all the ways that it would set up reward tiers. And eventually I was like, you know what? I'm never going to publish this. Like, I just need to do something. And that's why I have, like, no rewards, just, like, very, very basic tiers for starters. And I'm going to iterate on it. In the same way, trying to get, like, an OBS set up has been a real bottleneck for me. And I think maybe if I just, like, use the crummy YouTube Studio streaming tools, I'll have done it. And
so you're on Mac, right?
Yeah.
Look at Streamlabs OBS. Instead of the open source one, use the Streamlabs one. Even the newer versions of OBS do a lot more of it for you. One of the nice things is that the new versions of OBS, and they just added this fairly recently, will actually OAuth into your YouTube account. So it's not just you're giving it a stream key, it OAuths to your YouTube account. So a lot of the stuff you would have to normally manage in a separate window, like chats and things like that, will come up in there, which is pretty nice. So Don't like it's simple, right? Like you saw I frantically was fixing my scenes as you joined up because it turns out apparently if you're doing the window capture in OBS on Zoom, it captures a big blank window, probably something to do with hardware acceleration and what layer the I don't know. I'm a back end server guy, but something somewhere it didn't work. So I would don't worry about those details. Actually, I gave my best friend this piece of advice today, and I think it applies here as well, which is that it's hard to actually do something or to change something, which is why it's more fun to talk and think about changing or doing something sometimes. And often the best you can do is just do it, right? Like you just do it and get it done. If it launches, if it like really launches, then good. You have money to go hire an editor to go improve your thing. You have sort of the proof of concept there. And if not, then not. Or maybe you get popular when you realize it doesn't matter. It doesn't matter, right? Like, I mean, I'm streaming two guys with audio and like a thing, and we've had 5 people stop by and watch. So I mean, it's not. And that's maybe the other thing I would say as well is that I suspect you would have more instant success than I have, just because you have a bigger professional network, more years in open source than I do. But like, even with that in mind, don't necessarily expect immediate success. Just, do it, talk to it. I find it like, I don't want to say therapeutic isn't the right word, but when I'm having a bad, unproductive day, like sometimes it can be a second wind. It's like pair programming with the entire internet. And I don't mean that in the sense of like, they're not feeding anything to you, but sitting there explaining, they're all your rubber duck. The camera's your rubber duck. And that can unstick you even if you're just pair programming. So, I don't know. I think you should do it. I'll tune in. As one of your Patreon patrons, that's the reward I demand, is a video from Glyph. And then once you get your legs underneath, if you want to chat with me about J stuff, I'm happy to chat with you about J stuff.
Well, cool. Thank you very much for that boost of confidence. This has been a really fun conversation. I feel like we got really far afield, but I hope that
that's the point.
Folks watching and for the VOD, I think people get a lot out of it. So I'll.
Yeah, this is the thing that's funny about this is I remember we had a conversation once at Rackspace where you came and asked me some like ops minutia, and you're like, yeah, I'm like the big dev guy, and you're the guy who's been doing ops forever, and then I have this conversation with you, and you're like, yeah, I did DevOps before DevOps was a thing. You could have like written the book and been like the DevOps guy, but instead you're the twisted guy. So it's kind of interesting to hear that, like, I'm not sure I've so obviously been on the other end of someone's imposter syndrome before. But it's like, I don't know ops very well. And then it's like, no, you don't know traditional ops very well because you invented the ops that everyone's using in 2023, like back in 2005 or whatever. So congratulations, Glyph. Have a nice day. Like I said, let me know when your kid cracks quantum physics or something, and I'll be in on it.
All right, will do.
Hey, thank you so much.
Okay.
Thanks for stopping by.